in this example we've got 3 simultaneous equations and 3 unknown variables. So our aim is to try and find values for x, y and z that satisfy all 3 equations. So we're going to be using the elimination method, and it's very similar to what we did at GCSE when we just had 2 simultaneous equations. So if we have a look at the equations, the first thing we should notice is that the third equation only contains 2 variables. It's only got an x and a z. So what I would do is use the other 2 equations, 1 and 2, try and eliminate the variable y from that, so we're only left with an x and a z as well. And there's other ways of going about it, but I think this is probably the most direct. So what we're going to do, pair up equation 1 and 2. We need to get coefficients to match up, so I'm going to multiply equation 1 through by 2. And then I'm going to add on equation 2, and we should be left with x plus 12z equals 10. I'm going to label that as equation 4. Okay, so now I have 2 equations and 2 unknowns. If you have a look, we've got equation 3, which involves an x and a z, and equation 4, which involves an x and a z as well. So what we're going to do now is take 3 and 4 together and try and eliminate a further variable. So get rid of either the x or the z. Again, it doesn't matter what way round we do this, but I've decided to eliminate the x. So I'm going to take equation 3, keep it as it is, 5x plus 3z equals minus 7. I'm going to take the new equation, equation 4, times it by a negative 5, so I can add the 2 equations together to eliminate x. So once we do all that, you can see the working out. We are left with, once we add up 3 and 4, we'll be left with minus 57z equals minus 57. Solving that then to find z, we're left with z equals 1. So once we find z, we use that to find another letter. So the easiest thing would be either to put this into equation 3 or 4, that only involves x and z, to find x. So I've chosen to sub it into 4. So once we do that, we end up getting x equals minus 2. Final step then, take your answer for x, your answer for z, and substitute those back into one of the equations involving y. So again, it doesn't matter what one we pick, but I've decided to substitute it into equation 1. Doing that, I get y equals 4. Now remember from GCSE, it is very important that we check our solutions. So the mathematics behind this is pretty straightforward, but it is a lot of working out and it's quite easy to make a mistake. So just make sure you check all your solutions by substituting the values into one of your other equations. So because I used equation 1 to find my answer for y, I've chosen to use equation 2 to check my solutions. It only takes a minute. You can do it in your head, just make sure that you do it. Okay, this second example is slightly different from the previous one in that we're back to only having 2 simultaneous equations. However, one of them is linear, equation 1, and one of them is a quadratic, which is equation 2. When we encounter this style of problem, we solve them by substitution rather than elimination. So we find a value for one of the variables, either x or y, from the linear equation, and we substitute it into the quadratic equation. So what I'm going to do is first start by rearranging equation 1, and by doing that, I end up with x equals 6 minus 2y. What I'm going to do then is substitute this into equation 2. So replace the x's in equation 2 with a value of 6 minus 2y. So you can see the working out. I've substituted it into equation 2. All we have is a quadratic equation, so we're going to expand it, simplify it by collecting like terms, and then solve a quadratic. So if you just follow through the working out, doing the expansion of the brackets, simplifying, we get left with the final equation of our quadratic, 5y squared minus 18y plus 18 equals 5. Next step then, obviously bring the 5 to the left hand side, subtract 5 from both sides. To get the quadratic equation, 5y squared minus 18y plus 13 equals 0. So now it's up to us how we solve this. You can solve by factorising, or you can use your quadratic formula. It doesn't matter as long as you get your answers for y. So it's easy enough to do by factorising. Into double brackets, we get 5y minus 13 and y minus 1 equals 0. Solving that, we get 2 answers for y. We get y equals 13 over 5, or y equals 1. Now once we get to this point, Remember, simultaneous equations, we're trying to find two variables, x and y, so don't forget to substitute these back into equation 1 to find x. Now the reason why I've picked equation 1 is because it's a linear equation, it's much easier to work with. Try and keep it as simple and as straightforward as you can to eliminate silly mistakes. So substituting into equation 1, if we substitute in y equals 13 over 5, we end up getting an answer for x to be 4/5. And if we substitute in y to be 1, we get an answer of x equals 4. So our final solutions, x is 4/5 and y is 13/5, or x equals 4 and y equals 1. Again, please make sure that you check these solutions to make sure you haven't made any silly mistakes. Simultaneous equations are easy, straightforward marks, but it's very easy to make a mistake in all the working out, so just make sure you double check everything.